Okay, let's unpack this. What if I told you that calculus, the really abstract stuff like integration, what if it's actually working away in, like, your kitchen cabinet?
Yeah, that's a great way to put it.
Yeah.
And it's absolutely right. We're looking at a really fascinating real-world link today, something that connects math to, well, agriculture.
Yeah, and this topic, this deep dive, it actually comes straight from you, our listener. You send us some source material asking us to explore how differentiation and integration pop up in drying spices, like in the sun.
Right.
So our mission today is pretty specific. Figure out how integration helps measure something key in that whole drying
But
process.
what's really insightful and something your source material really nails is a problem the producers are up against. See,
Mm.
when you sun-dry spices, you've got to get a very specific amount of water out.
Mhm.
If you don't, you get spoilage, right? Mold, bacteria. Plus, you want the right texture, the right flavor concentration. You can't just uh, guess if it's dry enough.
Right, yeah, you need to actually know the total water that's gone by the end. Now, I guess you could measure how fast the water's leaving at any one point. That speed, that rate of change. That sounds like differentiation, doesn't it?
It does, exactly. Differentiation could tell you the instantaneous rate of water loss,
Yeah.
grams per hour at, say, 2 p.m. on a sunny afternoon.
Right.
But the real challenge, the one your source material points out, isn't knowing the speed right now. It's knowing how much total water has been removed over the whole drying time. Days, maybe.
Uh,
Yeah.
and that's tricky because the drying speed isn't just one number, is it? It's fast at the beginning when things are wet,
Much faster.
and then it slows way down as the spice gets drier. So just using the starting speed wouldn't work for the total.
Exactly right. That rate of water loss, it changes constantly. Depends on the sun, the humidity, how much moisture is even left inside the spice.
Yeah.
It's dynamic.
Okay.
So to get the total water removed over, hours or days, you need something that handles that changing rate.
So if you have a way to describe that changing rate, maybe you like weigh the spices every so often and make a model, a function. How do you get the total amount from that changing rate function?
Precisely. And that is where integration becomes, well, essential. It's the tool for the job. Integration lets you take that changing rate function
Yeah.
and basically add up all the tiny infinitesimal amounts of water lost at every single moment through the whole process. It sums up all those little contributions, even as the rate itself is going up or down.
Okay, so it's like saying, I know how fast water was leaving each minute, even though that speed changed all the time. Integration adds up all those tiny losses to give me the grand total. Is that about right?
That's the core idea, yes.
Okay.
And that final number, that total, it's incredibly valuable.
Why is that?
Well, it lets producers make sure every batch hits that target low moisture level.
Hmm.
Often it's a specific percentage that they need for, shelf stability and safety. It stops the mold and bacteria your source mentioned.
Right, the spoilage.
And it also helps figure out the final yield, how much dried spice you get from the fresh stuff.
So it takes this continuous, messy, changing process
Mm-hmm.
and boils it down to one number that says, yep, it's dry enough, or nope, needs more time, based on quality, safety.
That's it. It really shows how integration is fundamentally about finding the cumulative effect or the total accumulation when something happens at a changing rate over time.
So next time you're like sprinkling dried oregano on pizza or something, maybe pause and think, there's some calculus, some integration that might have helped get this spice just right for my pantry.
It's a beautiful practical example. Shows this math isn't just for textbooks,
Yeah.
It's a tool for understanding and controlling things in the real world.
Okay, so here's something for you, the listener, to chew on. Integration measures the total result of a changing rate.
Yeah.
Right. So where else in your everyday life? Where else might a changing rate be adding up to a total result that actually matters to you? Maybe think about traffic. The speed changes, but you care about the total travel time.
Or your electricity use. It changes minute by minute, but the bill shows the total kilowatt hours used.
Exactly. Keep an eye out for those connections.
They really are everywhere once you start looking.
Absolutely.